There is one direction almost no one has ever traveled, and it points straight up, away from the flat sheet on which the planets drift. It is a strange thing that we have made pictures of nearly every world we know, and yet no one has ever looked down upon our own Sunday and its family from above. 93 million miles away, that same fire turns quietly in the emptiness. Everything we have ever sent aloft was born drifting sideways, carried in the Earth's own slow current. We have wandered far out toward the soft edge of the Sunday's light, and still have almost never floated above it. Tonight, we drift gently upward, out of that flat plain. We will follow the two lone travelers that ever climbed free of the disk, pass slowly over the poles of the Sunday, and drift to the thin outer edge of the Sunday's great bubble. If someone you love is lying awake tonight, this is a soft place to leave them, a quiet corner of the sky to rest in while the day loosens its hold. So let the room grow dim and let the day settle into the mattress beneath you. There is nothing to reach for here and nothing you need to carry. Breathe out slowly once and let us begin. Picture the solar system the way the old diagrams draw it. The Sunday at the center and the planets circling around it. Almost always those drawings are flat. The worlds are laid out on a single level surface, like coins resting on a calm table, and that picture is very nearly true. Mercury and Venus, Earth and Mars, and the great outer giants all move within a few degrees of the same plane, a thin invisible sheet that runs straight through the middle of the Sunday. Astronomers call that sheet the ecliptic. Think of it as the level sea on which every world we know quietly sails. And tonight, softly, we are going to lift away from it and look back down. There is a quiet freedom in a night like this, when the only journey asked of you is the one your mind takes on its own. You do not need to picture any of it perfectly. Let the images come loosely. The flat disk of the planets, the small turning Sunday, the dark open space above, and let them blur and drift as sleep draws near. Nothing here needs holding. The facts are true whether you follow them or not, and the wonder keeps just as well whether you are awake to feel it or already halfway into dreams. This is a journey you can take with your eyes closed, and closed eyes are exactly where it is meant to lead. To understand why no one has ever looked down on the Sunday, it helps first to understand why the planets lie so flat. That flatness is not an accident of the moment. It is a memory, kept for billions of years, of the way the Sunday and all its worlds were born. Long ago, before there was an Earth or a single morning, there was only a wide cloud of gas and fine dust drifting in the dark between older stars. Clouds like that are enormous and cold and almost perfectly still, and they can hang in the quiet for a very long time. Then something gives one of them the gentlest nudge. Perhaps the slow pressure of light from nearby stars, or simply the patient pull of its own weight, and one small part of the cloud begins to sink inward toward its own center. As the cloud falls inward, it does the thing that every gathering, spinning thing does. It begins to turn faster. Whatever faint drift of rotation the cloud carried at the start grows quicker as it shrinks, the way a spinning skater draws in her arms and quietly speeds up without any effort at all. Once the cloud was many light years across and turning so slowly you could never have noticed. By the time it had fallen to something far smaller, that whisper of a turn had become a real and steady spin. Here is the quiet secret of it. A spinning cloud cannot stay a ball. Along the line of its spin, at the top and the bottom, Gravity pulls the gas straight inward, and nothing holds it back. So those regions collapse quickly and flatten. But around the middle, out along the equator, the spin flings the gas outward and slows its fall. Material there settles into a wide turning ring, instead of dropping all the way in. Over time, the round cloud is pressed from a ball into a plate, thick and bright at the center where the young Sunday is gathering, and thin and cool at the wide, drifting rim. Astronomers have a plain name for that shape. They call it a protoplanetary disk, which simply means a disk that planets come from, and they are no longer only a thing we imagine. With patient telescopes, we have photographed real disks around other young stars, glowing rings of dust with dark gaps carved into them, where unseen new worlds are sweeping their paths clean. Each of those pictures is a portrait of a solar system in the making, and each one is flat, for the very same reason ours is. Not everything in the solar system obeys the flat rule perfectly, and the small exceptions are lovely in their own way. Pluto and its distant kin ride paths, tilted more steeply than the planets, leaning out of the plane by more than we are used to. And far beyond them, in a great spherical shell wrapped all the way around the Sunday, drift the sleeping comets of what we call the Oort cloud, a vast round swarm that does not lie flat at all. Every so often, one of those comets falls inward toward the Sunday, and because it comes from that spherical shell, it can arrive from any direction, plunging down through the plane from high above or rising into it from below. When we see a bright long period comet in our skies, we are watching a visitor from the one part of the solar system that never flattened, a reminder that the tidy disk of the planets is only the innermost, best-ordered room of a much larger and rounder house. There is a homely image that captures the shape of it. Think of an old record turning on its player, flat and round, with a small raised label at its center. That label is the Sunday, thick and bright, and the fine grooves are the orbits of the planets, each a circle laid into the same level surface, all turning together around the middle. Even the asteroid belt, that broad scattering of rocky worldlets between Mars and Jupiter, lies mostly within this same flat record, circling in the plane like a band of dust caught in a groove. The rings of Saturn, in miniature, tell the very same story. A flat disk of ice and stone spread around a central world, flattened by spin exactly as the whole solar system was. Flatness, it seems, is simply what spinning gravity likes to make, at every scale, from a planet's rings to the great wheel of the Milky Way itself. There is even a way to see the plane, with your own eyes, on a clear dark night, far from city lights. Because the planets all ride so close to the same flat sheet, they appear from the Earth to move along a single line across the sky, the same line the Sunday follows by day and the moon by night. The ancients noticed this long ago and marked that line with the familiar figures of the zodiac, never quite knowing that what they were tracing was the edge of the great disk itself, seen from within it. When you spot 2 or 3 bright planets strung across the evening in a gentle arc, you are looking straight along the plane of the solar system, edge on from your own seat inside it. The flat sheet is not an abstraction in a textbook. It is written across the sky above your roof every clear night, in the quiet march of the planets along one shared and ancient road. Dwell for a moment on just how flat that ancient road really is. If you were to build a careful model of the solar system, a wide one, the planets circling out to a rim the size of a small pond, the entire thickness of their spread, top to bottom, would be no more than a whisper, thinner than the pond's own surface film. On that scale, the worlds do not fill a ball of space at all. They hug a single level plane, barely wandering above or below it. Some tilt their paths a degree or two, a few a little more. But next to the great width of their orbits, those tilts vanish into almost nothing. The solar system is, to a very good approximation, a flat thing floating in a round emptiness. And that simple fact is the whole reason the space directly above and below it has stayed so untouched. Within our own young disk, the dust did what dust does. Tiny grains drifted and touched and stuck, gathering into pebbles, then boulders, then bodies the size of mountains, and finally into the planets themselves, because every one of them grew from the same flat, turning plate. Every one of them inherited the same flat, turning motion. They were not scattered in all directions like bees around a hive. Instead, they were laid down together on one level surface, all circling the same way, like leaves carried on the slow surface of a single wide pond. That is why, billions of years later, the planets still lie so nearly in one plane. Earth's path and Jupiter's path and the paths of all the rest are tilted from each other by only a handful of degrees. If you could shrink the whole solar system to the size of a dinner plate and look at it edge on, it would seem as thin as a sheet of paper, with the Sunday a bright bead at the middle and the planets tucked close along the rim. The flatness is not a coincidence we happen to see today. It is the oldest habit the solar system has, older than the oceans, older than the ground beneath you, kept faithfully since before the Sunday first shone. And once you know a shape as old and as deep as that, a small question begins to open softly, the way a question does just before sleep. If everything we know lives on this one thin sheet, then what would it be like to leave it? What sits above the sheet and below it, in the great emptiness, the planets never visit? That is the direction we have almost never gone, and it is the direction we will drift tonight. There is a reason we stay on the sheet, and it is not for lack of wanting to leave. It is that we and everything we build are born already moving sideways along it, at a speed that is difficult to picture in a calm moment like this one. The Earth is not resting. It is falling around the Sunday in a great smooth circle, and to hold that circle, it travels at about 19 miles every second. Not every hour, every second. In the time it takes to read this slow sentence, the ground beneath you has carried you a few hundred miles along the Earth's path, sideways, across the flat sea of the ecliptic. You feel none of it, because everything around you is moving together at the very same pace, the way a passenger on a smooth night train feels perfectly still, while the dark country streams past outside. Now think about a rocket. When we launch a spacecraft, it does not begin from a standing start out in the quiet. It begins here, on this fast-moving Earth, already sharing all of that sideways speed. A probe lifting off from Florida is, from the Sunday's point of view, already racing along the plane at 19 miles a second before its engines have done anything at all. Whatever we send up is handed, for free, an enormous sideways motion in the direction the planets go. That gift is wonderful if you want to sail along the plane to another world. It is a quiet obstacle if you want to go up out of the plane entirely. To understand why, imagine standing at the edge of a wide carousel that is turning quickly. If you want to move around with the ride, that is easy. You are already going that way. But suppose you want to step straight toward the center or straight off the side, cutting across the spin. You feel at once how the motion fights you. The whole world is sweeping you along one way, and any attempt to go crosswise to it takes real effort and real strength. Space is gentler and emptier than a carousel, but the same principle rules it. To leave the plane, a spacecraft must fight against all that, inherited sideways, speed and turn its path upward, and turning 19 miles a second is not a small thing to ask. The cost is measured in a quantity engineers care about very much, which they call change in velocity. It is simply how much a spacecraft can alter its own motion with the fuel it carries. Every maneuver spends some of it. Reaching Mars along the plane spends a certain, manageable amount. But to swing a probe up and out of the ecliptic, to tilt its orbit steeply so that it rises high above the disk, would spend far, far more than almost any rocket can carry in fuel alone. The sideways sea we are born into is easy to sail across and expensive to climb out of. Even reaching the inner planets shows this hidden cost. You might imagine that flying to Mercury, the closest world to the Sunday, would be simple, a mere matter of falling inward toward the light. In truth, it is one of the hardest destinations of all, because to spiral down close to the Sunday, a spacecraft must shed a great deal of that inherited sideways, speed braking against its own motion, a whole way in. Missions bound for Mercury often take the long way, looping past Venus and the Earth again and again, spending years bleeding off velocity before they can settle into place. The sideways gift the Earth hands us shapes every journey we make, inward or outward, easy in some directions and dearly bought in others. Return once more to the image of the current, because it holds the whole truth gently. Imagine a wide, slow river, so broad you cannot see either bank, its surface smooth and its flow steady. Everything set upon it drifts along together, boats and leaves and swimmers alike, all carried the same way at the same pace, feeling no motion at all against one another. To travel with the flow is effortless. Crossing toward a far bank, angling gently against the current, is harder but possible with patient effort. But to climb straight up out of the river, up into the air above the water, is a thing no swimmer can manage by swimming. It needs a different kind of help entirely, a lift from somewhere outside the river's own logic. And there is a further reason the vertical direction stays so untraveled, beyond even the cost in fuel. Out along the plane, a spacecraft has helpers waiting. The planets themselves, each a handhold whose gravity can be borrowed to change course, for almost nothing. Straight up out of the plane, there is nothing at all. No world hangs above the Sunday's pole to swing past. No giant waits overhead to lend its motion. The vertical is not only expensive, it is empty of the very helpers that make the horizontal affordable. So to rise, a craft must either carry all the effort itself, which is very nearly impossible, or first travel sideways to a planet and let that planet do the lifting, which is exactly the roundabout path the climbers have had to take. This is the gentle prison of the plane. Though prison is far too hard a word for something so quiet, it is really more like a wide, calm current. Anything set adrift in it is carried along the plane without resistance. And to leave the current, you must swim hard across it, against the whole weight of your own motion. For 60 years of spaceflight, almost everything we have ever launched has simply gone with the current. Our probes have crossed to Mercury and drifted out past Neptune, but nearly all of them have stayed within a few degrees of the flat sheet, because that is the direction the current already flows. Up and down, above and below, have stayed almost entirely unvisited, and yet not entirely, because a small handful of times, patient people have looked at that current and asked a lovely question. If our rockets are not strong enough to climb straight out of the plane, might there be another way up, one that does not fight the current with brute force, but borrows the strength of something far larger than any rocket we could build? That question has an answer, and the answer is a planet. But we will come to that gently, in its turn. For now, simply rest in the picture of it. A whole civilization, born sideways, drifting along one thin bright sheet, dreaming quietly of up. The first traveler ever to break free of the plane and rise above the Sunday did not go up by going up. It went up by going out, all the way out to the largest planet in the solar system, and letting that giant world throw it skyward. Its name was Ulysses, and its story is one of the quietest, most elegant journeys we have ever made. Ulysses was built together by the European Space Agency and NASA, and it was lifted off the Earth in the autumn of 1990, carried up in the cargo bay of a space shuttle and released gently into orbit. From there, its true voyage began. The people who designed it faced exactly the difficulty we have just described. They wanted to send a probe up and over the poles of the Sunday, into a steep path that no craft had ever flown, and no rocket then or now could push a spacecraft directly into such an orbit. So they chose a wonderfully patient trick instead. Rather than fighting the plane, they would first fly the long way outward, 500 million miles out to Jupiter, and let the giant planet do the lifting for them. The trick is called a gravity assist, and it is one of the gentlest and cleverest ideas in all of space travel. When a small spacecraft passes close to a large moving planet, it falls into the planet's gravity, curves around it, and swings back out again. If the geometry is chosen with care, the craft leaves that encounter traveling in a new direction, and at a new speed, having quietly borrowed a little of the planet's own vast motion. The planet is so enormous that it never misses what it gives. A whisper of Jupiter's momentum, far too small for the giant to notice, is more than enough to fling a small probe onto a wholly new road. Only Jupiter would do for a maneuver so bold, and it is worth pausing on why. To bend a spacecraft's path as sharply as leaving the plane requires, and to lift it into so steep an orbit, the helper must be immense. Jupiter is by far the largest planet in the solar system, more massive than all the others combined, with a gravity so deep and commanding that it alone could turn Ulysses through the great angle needed. No smaller world could have done it. So the little probe's road to the poles of the Sunday ran, of necessity, straight past the throne of the mightiest planet we have, borrowing a single sip of the giant's motion to pay for its whole long climb. For all the elegance of the plan, it asked above all for patience. The outward cruise to Jupiter took Ulysses well over a year, more than a year of sailing across the flat plain in the ordinary way, gathering nothing but distance, waiting for the one moment when the giant would take hold. There is a quiet lesson folded into that long wait. The most graceful path is rarely the most direct. To go up, Ulysses first spent a year going out, trusting a plan whose whole reward waited at the far end of a long and seemingly ordinary journey. And when the moment finally came, it lasted only hours. When it was done, the little probe found itself somewhere genuinely new. It now traced a long looping orbit that carried it high above the Sunday and far below it, crossing the plane twice each circuit and spending the rest of its time out in the untenanted space above and beneath the planets. No other craft shared that orbit. Not one world lay along it. It was the first, and for a long time, the only inhabitant of the vertical, a single small traveler circling the Sunday, the tall way, while everything else went round the flat way far below. There is a particular quiet to that image. A probe sailing over the top of the Sunday through a region no eye had ever occupied, keeping its long watch entirely alone. The launch itself carried a small distinction worth a smile. To fling Ulysses outward toward Jupiter quickly enough, it was mated to powerful upper rocket stages after leaving the shuttle, and for a brief while after those stages fired, the little probe became the fastest human-made object ever to leave the Earth, racing away from home faster than anything before it. It needed that speed. The road to Jupiter is long, and the sooner Ulysses arrived, the sooner it could begin the real work of climbing out of the plane. So it departed in a hurry, this quiet listener setting a record for haste at the very start of a mission whose deepest virtue would turn out to be patience. Ulysses reached Jupiter in February of 1992, after more than a year of sailing outward across the plane. It slipped close above the giant's cloud tops, deep in the pull of the most powerful gravity of any planet we have, and Jupiter took hold of it and turned it. Where the probe had been traveling outward along the flat sheet like everything else, it now came away bent sharply downward and southward, hurled clean out of the ecliptic and onto a steep new path that would carry it up and over the Sunday from far below. In a single graceful pass, without spending scarcely any fuel, Ulysses did the one thing our rockets alone could not. It left the plane. There is something to sit with quietly in that maneuver. To rise above the solar system, the first thing Ulysses had to do was travel in what looks, at a glance, like exactly the wrong direction. It went outward and away from the Sunday, 500 million miles into the cold, in order to gain the height it needed to come back and pass over the Sunday's poles. The path to up ran first through far out. That is often the shape of the most patient journeys. You go a long way around, seemingly astray, and only much later do you understand that every mile of it was carrying you exactly where you needed to be. From Jupiter, Ulysses fell back inward along its new, steeply tilted orbit, a long, slow arc that would swing it beneath the Sunday, then high up over the top, then back down again, over and over, for years. It was now the only object ever made by human hands to leave the flat road of the planets and circle the Sunday from above and below. No world, no moon, no other probe kept it company up there. It sailed alone, in a part of the sky that until then had held nothing but sunlight and silence. One more thing about Ulysses is worth holding gently, because it matters for everything that follows. It carried no camera, not a single one. It was never meant to take a photograph of the Sunday from above, and it never did. Instead, it carried delicate instruments to feel things a camera cannot see, The pressure of the solar wind, the trembling of magnetic fields, the faint sleet of particles streaming out from the star. Ulysses did not go up there to look. It went up there to listen. And what it heard in that unvisited quiet above the Sunday's poles gently overturned what we thought we knew about our own star. We will follow it there next, up and over the top of the Sunday, into a stillness no instrument had ever tasted before. In the autumn of 1994, Ulysses arrived somewhere no craft had ever been. Rising along its steep, tilted orbit, it climbed high beneath the solar system and passed directly below the south pole of the Sunday. For months, it hung out there in the deep south of the sky, farther below the plane than anything we had ever sent, quietly feeling the Sunday from an angle no instrument had felt before. What it found was not what many had expected. Down there, streaming out from the pole, the solar wind blew steady and remarkably fast. The solar wind, if the phrase is new to you, is the constant outward breath of the Sunday, a thin stream of charged particles that flows off the star in every direction and fills the whole solar system. Near the Sunday's equator, out along the plane where the Earth rides, that wind is gusty and slow and tangled, always changing its mind. But over the poles, Ulysses found something calmer and grander, a smooth, swift river of wind pouring steadily outward at around 1.5 million miles an hour, faster and far more even than the wind we know down here on the flat sheet. The poles of the Sunday, it turned out, breathe differently from the middle. Scientists came to understand where that fast, smooth polar wind is born. At the poles of the Sunday, when the star is calm, the magnetic field opens outward into space, rather than looping back down to the surface, leaving great open regions that appear darker and cooler in certain kinds of light. These open regions are called coronal holes, and they act like wide unblocked doorways through which the Sunday's outer atmosphere can stream away freely and fast. Near the equator, by contrast, the field is more often closed, curling back on itself in loops and arches that trap the gas and slow its escape. So the wind that does get out is gustier and more tangled. The poles, standing open, breathe out their long, steady rivers. Their waist, half closed, breathes in fits and starts. There was another quiet discovery waiting up there as well. Because the polar wind flows so smoothly and the field is so open, the poles are also where certain particles from the wider galaxy can most easily drift inward toward the Sunday, sliding in along those open field lines from the space between the stars. In feeling the poles directly, Ulysses helped us understand not only how the Sunday's breath leaves, but also how a little of the galaxy's own thin weather comes in through those same high open doorways. It was, all of it, knowledge gathered in a place of extraordinary stillness. Out there, high above or below the Sunday, alone in a part of the sky nothing else had ever visited, the little probe drifted through months of quiet, patiently reading a wind that had blown unwitnessed, since long before there was anyone to wonder about it. All of this mattered because the wind is how the Sunday touches the rest of the solar system. That endless stream shapes the tails of comets, brushes against the magnetism of every planet, and fills the whole vast bubble we live within. To learn that the wind is not one uniform thing, but a structured flow, fast and smooth from the open poles, and slow and gusty from the closed equator, was to understand the Sunday's reach far better than before. Ulysses drew the first true map of that reach in 3 dimensions, not merely around the Sunday's waist, where we had always measured, but over its top and under its bottom as well. For the first time, we could picture the solar wind as it really is, a great 3-dimensional fountain with a different character at its poles than at its middle, rather than the flat, simple outflow we had always imagined from our fixed seat upon the plane. There is a gentle irony in how we came to know the poles. We learned the feel of the Sunday's most hidden regions from a spacecraft that could not see and would not have known a sunrise from a shadow. It gathered no images, only impressions, the push of particles and the lean of magnetic fields. And from those bare impressions we built our first true understanding of the top and bottom of our star. That, in itself, is a reminder that seeing is not the only way of knowing. Sometimes the deepest knowledge of a place comes not from a picture of it, but from patiently feeling what it does. The way you might know the sea in the dark by the sound and the salt and the cool of the air, long before the first light shows you its face. Ulysses could measure this because of what it carried and because of what it lacked. Remember that it had no camera. It could not send back a portrait of the pole glowing beneath it. What it could do was taste the wind directly, count the particles as they streamed past, and feel the shape of the magnetic field threading through them. So the first knowledge we ever gained of the Sunday's poles came not as a picture, but as a set of quiet readings, a description in numbers and fields rather than in light. We knew what it was like up there, in the way you know a room in the dark, by the movement of the air long before we could ever see it. In the summer of 1995, Ulysses completed the other half of its long arc. It swept up from beneath the Sunday, crossed the plain, and rose high above the North Pole. Looking down now from the top, and it found the Northern Pole breathing much the same way as the South, the same fast, smooth polar wind streaming out into space. For the first time, we had felt both ends of the Sunday, the top and the bottom, the two places the flat sheet never lets us stand. The star we thought we understood so well was quietly revealed to have a structure we had never known, a calm and rushing wind at its poles, quite unlike the restless wind at its waist. Ulysses was so faithful a traveler that it made the journey more than once. Its long orbit carried it up and over the Sunday again near the turn of the century, and once more in 2007 and 2008, each pass falling at a different moment in the Sunday's slow rhythm of activity. Because of that, it saw the poles not only when the Sunday was calm, but also when the Sunday was stormy and its magnetism was tangled and loud. It watched the polar wind change with the star's own long seasons and gave us not a single snapshot in feeling but a patient record spread across nearly 2 decades. The little probe kept working far longer than anyone had promised it would. Year after year, it sailed its lonely tilted loop, the only made thing ever to know the Sunday from top to bottom, until at last, in the middle of 2009, after more than 18 years aloft, its signal grew too faint to hear, and the mission gently came to its close. Ulysses fell silent up there on its steep and beautiful orbit, still circling the Sunday from above and below, as it will for a very long time to come. It never took a picture. And still, it changed forever how we picture our own star, simply by being the first to rise and listen from the one place no one had ever stood, Let us pause for a moment above the pole and ask a simple question, the kind that is easy to overlook. What is a pole of the Sunday, really? And why had we never seen one until so recently? The answer is gentler and more surprising than you might guess. Our Sunday turns, just as the Earth does, though it is not solid, and so it turns in a curious way. Being a great ball of glowing gas, it does not spin all in one piece. Its middle, around the equator, comes around once about every 25 days, while the regions near its poles lag behind and take closer to 35 days to complete a single turn. The Sunday rotates faster at its waist than at its top and bottom, sliding past itself, and this slow difference is part of what winds up the Sunday's magnetism over the years. But like the Earth, the Sunday has an axis, an invisible line it spins around, and where that line comes out at the top and the bottom are its two poles. Here is the quiet part. That spin axis is very nearly straight up and down with respect to the plane of the planets. The poles of the Sunday point up out of the ecliptic and down below it into exactly the empty directions the planets never travel. So from the Earth and from almost every spacecraft we have ever flown, we do not look at the Sunday's poles at all. We see the Sunday forever from the side, from out along its equator, the way you might only ever see a friend's face in profile, and never once straight on. The top of the Sunday and the bottom of the Sunday are turned away from the flat road we ride, tilted just out of our line of sight, hidden not by distance, but by the angle we are stuck at, and the poles are not merely a matter of geometry. They are where some of the most important things about the Sunday quietly happen. The Sunday's magnetic field, the great invisible force that shapes its storms and its wind, is anchored most strongly at the poles, much as a bar magnet is strongest at its two ends. It is from the poles that the fast, smooth polar wind Ulysses found comes streaming out. And it is at the poles that the Sunday does one of the most remarkable things any star can do. Roughly every 11 years, at the peak of its cycle of activity, the entire magnetic field of the Sunday turns itself over. North becomes south, and south becomes north. The whole vast magnetism of the star flipping end for end, slowly and silently, on a rhythm older than any calendar. That great turning begins and shows itself first at the poles. The way the Sunday builds toward that great turning is a slow and beautiful piece of clockwork. Because the star spins faster at its equator than at its poles, it gradually winds its own magnetic field around itself, stretching and tightening it year by year like a rubber band, twisted a little at a time. As the field grows tangled and strong, it breaks through the surface in places to make sunspots, those cooler dark patches that come and go across the Sunday's face. Near the start of each cycle, the spots appear in the middle latitudes, and as the years pass, they form closer and closer to the equator, drifting sunward in a slow procession that, when charted over time, traces out the soft shape of butterfly wings. All the while, the old field is being carried up toward the poles, where it gathers, reverses, and quietly sets the stage for the next great flip. Watching the poles, then, is a little like watching the hands of the clock that keep the Sunday's long rhythm. And this is not knowledge for its own sake alone, though it would be worth having even if it were. The Sunday's cycle of activity governs the storms it sends our way. The bursts of wind and particles that can brighten the auroras, and at their strongest, ripple gently through the technology we lean upon. To forecast that weather, to know years ahead whether the Sunday is climbing toward a busy peak or settling into a quiet trough, it helps enormously to read the magnetism gathering at the poles, where the next cycle is even now being wound. Hold on then to that gentle image of the profile, the friend whose face you have only ever seen from the side. For all our closeness to the Sunday, for all the centuries we have watched it and measured it and learned to read its moods, we had somehow never once seen it fully face to face at its poles. We knew its equator intimately and its poles hardly at all. It is a little like living your whole life beside a great mountain, knowing every fold of its lower slopes, yet never once glimpsing its summit, always hidden just above the line of sight. The summit of the Sunday, its true poles, waited through the whole of human history for someone to climb high enough to look. Consider how near and yet unseen those poles have been. The Sunday is the nearest star to us by an enormous margin, close enough to warm your face on a spring afternoon, close enough that its light reaches us in only 8 minutes. And still, of all the countless things we have managed to see, its own poles were among the last to be revealed. Distance was never the barrier. A thing can be near and familiar and beloved and still keep one face turned away, simply because of the angle at which we happen to stand. The poles of the Sunday were hidden not across a gulf of light years, but behind a tilt of a few degrees, and that small tilt held them from our sight for the whole of history. So the poles are not a dull cap at the ends of the Sunday. They are something closer to the source of its deepest weather, the place where its long heartbeat of magnetism can best be read. To understand why the Sunday grows stormy and then calm again across its 11-year cycle, why it sends out the flares and the streams of particles that paint our skies with auroras, it would help enormously to watch the poles directly, to see the magnetism gathering and turning at the very top and bottom of the star. And that is the one view the flat plane has always denied us. For all of history then, we have studied the Sunday the way you might try to understand a spinning top by only ever looking at its middle, never at the point it spins upon. We have learned a great deal that way, more than our ancestors could have dreamed. But the ends of the axis, the true poles, stayed just out of view. Waiting, Ulysses had risen high enough to feel them, to taste their wind and sense their fields. Yet even Ulysses, with no camera aboard, had never actually seen them. To truly look down upon a pole of the Sunday, to make a picture of it in light, the world would have to wait for a second climber, one built for a single tender purpose, not to listen this time, but to look. More than 30 years after Ulysses first rose above the plain, a second traveler set out to finish what the first had begun, and to do the one thing Ulysses never could. It would climb up out of the ecliptic like its ancestor, but this time it would carry eyes. Its name is Solar Orbiter, and unlike the lonely listener before it, it was built to bring home the first true pictures of the Sunday's poles that human beings have ever seen. Solar Orbiter was built by the European Space Agency together with NASA, and it lifted off from Florida in February of 2020, at the very start of that quiet, difficult year. In its design, you can feel everything we have learned. It carries a heavy, patient shield across its front to hold off the heat of the Sunday as it flies close, and behind that shield a suite of telescopes and cameras peer out through small, carefully shuttered windows. Through them, it can watch the Sunday in kinds of light our eyes cannot see, mapping the magnetism on the surface and the million-degree glow of the outer atmosphere. But to point those cameras down at a pole, it faces the same old difficulty every climber faces. It has to leave the plane, and a rocket alone cannot lift it there. So Solar Orbiter uses the same patient wisdom Ulysses did, only turned to a nearer helper. Instead of flying all the way out to Jupiter for a single great push, it makes repeated close passes by Venus, again and again, borrowing a little of that planet's motion each time. Every time the probe swings past Venus, the encounter tilts its orbit a bit further out of the flat sheet, like a child on a swing, gaining a little more height with each careful push from behind. It is a slow way to climb, spread over years, but it costs almost no fuel, and it does something a single leap could not. This lets the probe rise gradually, returning to the Sunday again and again, each time looking down from a slightly steeper angle than before. Everything about Solar Orbiter is shaped by the nearness it seeks. As it swings close to the Sunday, at times closer than the planet Mercury ever comes, it must hold off a flood of heat and light, and so it flies always behind a broad shield built to shed that heat, its instruments sheltered in the cool shadow behind. The cameras that need to see the Sunday peer out through small doors in the shield, doors that open only briefly and then close again, letting each telescope take its careful look before retreating back into shade. It is a craft built to steal glances at a fire, edging near enough to see in fine detail, yet never so near or so long that the heat overwhelms it. And from behind that patient shield, it maps the magnetism crawling across the Sunday's surface and the vast glowing loops of its outer atmosphere, all while slowly tilting toward the poles no other camera had faced. It is worth noting that Solar Orbiter is not the only craft to have flown close to the Sunday in these years. Another probe, built to dive nearer to the star than anything before it, has swept again and again through the very outer edge of the Sunday's atmosphere, closer than any machine has ever gone. Yet even that daring craft stays down within the plane, circling the Sunday near its equator, sharing the same flat road as everything else. It goes nearer than Solar Orbiter, but never higher. And that is the quiet distinction at the heart of tonight. Going close to the Sunday and going above the Sunday are entirely different journeys. Many things have gone close, only two have ever truly gone above. When the first of Solar Orbiter's long-awaited images began to arrive, they did not look like much to an untrained eye, only a faint and grainy view of a mottled surface tipped at an unfamiliar angle. But to the people who had waited a lifetime for them, they were extraordinary. The first light ever gathered from a place we had never been able to see. In those early frames, the magnetism at the pole appeared jumbled and mixed, exactly as one would expect near the turning point of the Sunday cycle, when the old field is breaking up before the new one settles in. Each image was a small door, opening onto a region, hidden for the whole of history, and Solar Orbiter is only beginning. By the middle of this decade, those patient passes by Venus had carried Solar Orbiter to an orbit tilted well out of the plane, something on the order of 17 degrees above the ecliptic and rising, with more Venus encounters still to come to lift it steeper yet, toward an eventual tilt of around 33 degrees. It may not sound like much. 17 degrees, then 24, then more. But every one of those degrees lifts the cameras higher above the Sunday's waist and tips them further toward its pole, into a view no spacecraft with eyes had ever held. And from that gently rising vantage, Solar Orbiter has begun to send home the pictures we waited all of history to see. The first real images looking down toward a pole of the Sunday, faint and precious and utterly new. Think for a moment about what that means. For thousands of years, every human being who ever looked at the Sunday, every astronomer with every telescope, every earlier probe with every camera, saw the same face of it, the equator, the side. And then, in our own quiet years, a small craft riding a staircase of Venus flybys finally tilted far enough to catch the top and the bottom in light for the first time. The poles of our own star, hidden in plain sight for the whole of human history, behind nothing more than an inconvenient angle, at last turned toward a lens. It is one of those achievements that makes almost no noise in the world, and yet quietly rewrites a page in the oldest book we have, the Book of the Sunday. Solar Orbiter is still climbing, still swinging by Venus, still lifting itself degree by patient degree toward that fuller view of the poles. In the years ahead, its pictures will only grow clearer and more complete, until we understand the top and the bottom of the Sunday, nearly as well as we understand its middle. Two climbers now, then separated by a generation, one that rose to listen and one that rose to look. Between them they have taught us that the Sunday is not the simple, even ball it appears to be from our fixed seat on the plane, but a turning, breathing thing with poles all its own. And feeling that, a new wonder opens gently outward. If the Sunday breathes this wind from its poles and its equator alike, then where does all that wind go? How far does the Sunday's breath reach, out beyond the last planet, into the dark? That is the next height we drift toward. We have felt the wind at the Sunday's poles and the wind at its waist. Now, let us follow that wind outward and see where it goes, because it goes much farther than you might imagine, and where it finally stops marks the true edge of everything we can call home. The solar wind never rests. Every second of every day, the Sunday breathes out a thin, endless stream of charged particles in all directions at once. A steady exhaling that has continued for billions of years and will continue for billions more. It is not a strong wind by earthly measure. The gas is so thin that near the Earth, only a few particles drift through any small space at a time. A breath so faint you could never feel it on your skin. Yet it moves astonishingly fast, sweeping outward at hundreds of miles every second, and it never stops coming. Slow and thin though it is, its constancy makes it mighty. Given enough distance, that gentle breath fills a volume larger than anything the mind easily holds. Picture the Sunday, then, not as a still lamp hanging in the dark, but as a source forever pouring itself outward, a fountain of the faintest mist rising in every direction into the night. The mist rushes past Mercury, past Venus, past the Earth, where it brushes against our planet's magnetism, and on quiet nights near the poles, lights the sky with the soft green and violet curtains of the aurora. It rushes on past Mars, out through the wide gaps between the giant planets, past Jupiter and Saturn, past Uranus and Neptune, and still it does not stop. The Sunday's breath reaches far beyond the last planet, out into a darkness so distant that sunlight itself has grown pale and small. As it travels, the wind carries something with it that turns out to matter a great deal. It carries the Sunday's magnetic field, dragged outward and wrapped by the Sunday's slow spin into a vast, gentle spiral, like the curving arms of water flung from a garden sprinkler turning on a lawn. That magnetic breath, streaming out and spiraling as it goes, does not simply fade into nothing. It pushes. Gently it presses outward against the thin gas that lies between the stars, the faint drift of atoms that fills the spaces of the galaxy. And in pushing against that gas, the Sunday's wind does something quietly wonderful. It clears itself a space. Slowly, it blows an enormous bubble. There is a lovely human story folded into that outward spiral. Not so long ago, most scientists imagined the space between the planets to be simply empty, a still and silent vacuum. Then, in the middle of the last century, a young physicist named Eugene Parker worked out that the Sunday's hot outer atmosphere could not sit still, that it must forever be flowing outward, filling all of space with a steady stream. Many doubted him at first, but when the earliest probes flew out beyond the Earth and felt that very stream blowing past them, exactly as he had foreseen, the solar wind passed from a bold idea into a measured fact. The gentle spiral the wind traces as it flows outward still carries his name, a quiet monument to the notion that the Sunday does not merely shine, but breathes. When that breath reaches the Earth, we are mostly shielded from it by our planet's own magnetism, which wraps around us like a soft, invisible cloak and turns the wind aside. But near the far north and far south of the Earth, some of the arriving particles are funneled down into the upper air, where they set the thin high gases glowing in slow curtains of green and rose and violet. Those are the auroras, the northern and southern lights, and they are nothing less than the Sunday's distant breath made visible, painted across our own polar skies. Every shimmer of the aurora is a small meeting between the wind of the Sunday and the shelter of the Earth, a gentle touch from a star 93 million miles away. For all its constancy, the wind is astonishingly light. In a whole year, the Sunday breathes out only the tiniest fraction of itself this way, a loss so small against its enormous bulk that it will go on shining unbothered for billions of years to come. And yet that thin, ceaseless breath spread across the vastness is enough to fill a region larger than we can easily picture, out past every planet, past the farthest comets we can track, to a wall so distant that light itself, the fastest thing there is, needs many hours to cross from the Sunday to reach it. That is the quiet grandeur of the solar wind. Almost nothing, blowing forever, adds up to a shelter beyond imagining. You can feel this same patient arithmetic in gentler things closer to home. A slow drip fills a great cistern given time. The softest current, never resting, carves a canyon out of solid stone. And the wind that scarcely stirs a leaf will, over centuries, lean a whole forest in one direction. The Sunday's breath belongs to that same quiet family of forces, the ones too faint to notice in a moment and too persistent to resist across an age. It does not hammer out its bubble in a burst. Rather, it exhales it softly and without pause. For as long as the star has shone, until the gentlest of breaths has become the largest structure in the whole neighborhood of the Sunday. That bubble has a name, one worth saying softly, because so few people ever hear it. It is called the heliosphere, which means simply the sphere of the Sunday, the great rounded region of space that the Sunday's own wind holds open against the galaxy beyond. Everything you have ever known lives inside it. Every planet, every moon, every comet, every spacecraft we have flown, the Earth and everyone upon it, all of us drift together within this single vast bubble that our star blows around itself. We do not usually think of ourselves as living inside anything, yet we do. We live deep within the Sunday's exhaled breath, in a sheltered pocket carved out of the wider dark, and the wall of that pocket lies farther away than almost any distance we have ever measured. There is a soft comfort in that thought, the kind that settles well towards sleep. The Sunday is not only the light we see and the warmth we feel. It is also the maker of the very space we live in, holding back the cold, thin currents of the galaxy. The way a fire on a still night pushes back the surrounding dark and makes a warm room out of the open air. Within its bubble, we are held, and it is a long, long way to the edge of that shelter, farther than the wind seems to have any right to reach. Where exactly does the Sunday's breath finally give out, and where is the wall of our bubble? To find it, we must drift farther from home than anything alive has ever gone, out past the last planet, into the deep where two lonely travelers are still sailing. Let us try gently to feel the size of this bubble, because its scale is a large part of its quiet grandeur. The planets, which seem so far flung to us, are gathered close around the Sunday, near the very heart of the heliosphere. Neptune, the outermost planet, orbits at a distance we could call the near shore of the bubble, and even reaching Neptune takes a spacecraft more than a decade of steady travel. Yet the wall of the heliosphere lies far, far beyond Neptune. It sits roughly 4 times as distant as Neptune from the Sunday, 10 billion miles and more out into the dark, so remote that the Sunday, seen from there, would be little more than the brightest of the stars. Everything familiar, then, is huddled in the innermost part of this shelter. If you imagine the heliosphere shrunk to the size of a quiet house, all the planets would fit inside a single small lamp, burning in the middle of one room, and the outer walls of the house would stand impossibly far off in the dark. Almost the entire bubble is empty of worlds. It is a vast, calm, nearly featureless volume filled with nothing but the thinning solar wind, growing colder and quieter and lonelier the farther out you drift, until at last you approach the wall where the Sunday's breath meets the breath of the galaxy. That wall exists because our Sunday is not sitting still in an empty void. It is moving, carrying its whole family of planets along with it, drifting through the galaxy at a fair pace as it makes its own enormous slow orbit around the distant center of the Milky Way. And the space it moves through is not truly empty. Thin as it is, the region between the stars is filled with a faint gas of its own, a drifting current of atoms astronomers call the interstellar medium. So the Sunday is forever sailing forward through this thin galactic gas, its bubble of wind pressing outward, the galaxy's gas pressing gently back, and where the two meet and balance, the heliosphere finds its edge. Because the Sunday is moving, the bubble is not a perfect sphere, despite its name. It is shaped a little by its own travel, much as any object moving through a fluid is shaped by its passage. On the side facing the direction of the Sunday's motion, where the bubble pushes into the oncoming galactic gas, the wall is pressed closer in, rounded and firm like the front of a ship meeting the water. Behind, on the trailing side, the bubble may stretch out into a long, soft wake. We live near the middle of this drifting vessel, carried along inside it through the galaxy, sheltered from the interstellar current by the thin, ceaseless pressure of our own star's breath. The gas the Sunday is sailing through is not the same everywhere, and we happen to be drifting through a particular wisp of it just now. Our whole solar system is presently passing through a faint, warm cloud of interstellar gas. One of many such clouds that drift through this corner of the galaxy, each thinner than the finest mist and stretching across many light years. We will remain within this particular cloud for a long while yet, tens of thousands of years at least, before the Sunday carries us out the far side of it and on into whatever lies beyond. The bubble around us is shaped in part by the pressure of whatever cloud we happen to be crossing, so that over the vast stretches of time, as the Sunday wanders through denser and thinner patches of the galaxy, the heliosphere itself must slowly swell and shrink in answer, breathing on a timescale far longer than any life. How well the bubble shelters us changes gently too, in step with the Sunday's own cycle. When the Sunday is active and its wind is strong, the heliosphere pushes outward more firmly and turns aside more of the galaxy's incoming particles, drawing its protective cloak a little tighter. As the star grows quiet, the bubble softens and lets a little more of that thin galactic sleet drift inward, so the shelter we live in is not a fixed and rigid wall, but a living, breathing boundary, expanding and easing with the slow moods of the Sunday at its heart. For all its unimaginable size, the heliosphere answers to the Sunday as closely as a tide answers to the moon, and we ride within it, held and gently rocked, mostly unaware that any wall is there at all. So picture, as you settle deeper towards sleep, the great nested shelter we live within. Farthest out lies the thin drifting gas of the galaxy. Inside that stands the vast rounded wall of the bubble, holding the galactic current at bay. Within the wall spread the wide, calm, nearly empty reaches of the heliosphere, filled only with the thinning wind. Closer in, near the center, gathers the small, bright family of the planets, riding their flat rings around the Sunday. And nearest of all, upon one of those pale rings, sits the Earth, and your own quiet room, and the bed, and the slow rise and fall of your breathing. Shelter within shelter within shelter, each one nested inside the next, all the way out to the wall of the Sunday's own making. It is a quiet comfort to belong to a bubble. We tend to think of home as the ground under our feet, or the walls of a house, or at most, the round blue world itself. But home reaches much farther than that, all the way out to the faint, invisible wall where the Sunday's wind meets the galaxy, and everything inside that wall shares in the same shelter. The comets and the distant icy worlds, the two Voyagers still sailing, the light of the Sunday and the breath of the Sunday alike. All of it is held within one boundary, one enormous quiet room. You are not only a resident of the Earth. In truth, you are a resident of the heliosphere, tucked deep in its warm inner corner, as much at home in it as a sleeper is in a darkened house at night. There is one more gift the bubble gives us, and it is a tender one to rest on. Out in the wider galaxy, Space is crossed by a sleet of high-energy particles, born in distant, ancient starbursts, tiny fast travelers that stream through the Milky Way from every direction. The Sunday's bubble holds a great deal of that incoming sleet at bay. Its magnetism, wrapped through the outflowing wind, deflects and softens the harshest of those particles before they can reach the inner rooms where the planets lie. The heliosphere is not only the space the Sunday makes for us. It is also a kind of gentle shelter, a soft wall between us and the fiercer weather of the galaxy, quietly doing its work for as long as the Earth has existed without our ever having to notice. So this is the bubble we live in. Enormous, calm, invisible, and carried forward through the stars by the star at its heart. We have known of it for less than a lifetime, and we have only ever measured its walls from the inside, feeling for them the way you might feel for the edges of a dark room with your hands outstretched. To actually reach those walls, to cross them and touch the boundary between the Sunday's realm and the galaxy beyond, would take a journey of decades into the emptiest emptiness. There is, remarkably, 2 small craft have made exactly that journey. And where they finally arrived, out at the wall of the world, is one of the quietest frontiers human beings have ever reached. The 2 travelers that reached the wall of the bubble are Voyager 1 and Voyager 2, and by now they are the farthest human-made objects in all of existence. They set out from the Earth in the summer and early autumn of 1977, when much of the world was younger, on what was meant to be a brief tour of the outer planets. That tour they completed long ago. And then, having seen the giants, they simply kept going, outward and outward, for decade upon decade, into regions no plan had ever imagined they would reach. The edge of the heliosphere is not a single sharp line, but a gradual frontier, crossed in stages, and the Voyagers passed through each stage in turn. First comes a place called the termination shock. Out there, roughly 10 billion miles from the Sunday, the solar wind, which has been rushing outward at hundreds of miles a second, all the way from the star, suddenly slows. It has finally pushed, as far as it easily can, against the pressure of the galaxy ahead, and like a fast river, spreading into a broad, shallow delta, it abruptly loses its speed and grows dense and warm and turbulent. Voyager 1 sailed across that slowing boundary in 2004, and Voyager 2, on its own separate path, crossed it in 2007. For the first time, our machines had reached the place where the Sunday's wind begins to yield. It is worth resting for a moment on what these 2 travelers are and how far they have come. Each Voyager is a modest thing, a small bus of instruments and antennas, drawing its power from the slow, steady warmth of a compact generator that has been quietly running since before most people alive today were born. That power fades a little each year, and so, one by one, the instruments are gently switched off to save what remains. The craft growing simpler and more frugal as they age, husbanding their last strength for the long sail ahead. Each also carries, fixed to its side, a golden record, a small disc engraved with sounds and images of the Earth, a greeting sealed for whatever or whoever might one day come upon it, drifting in the deep. They were sent out as explorers and messengers both, and they have kept faith with both callings across nearly half a century of flight. Between the termination shock and the true outer wall lies a broad and curious region called the heliosheath, where the slowed solar wind grows thick and turbulent and swirls in great slow eddies, piling up against the boundary ahead like water backing up behind a gentle dam. The Voyagers spent years crossing that thick borderland, feeling their way through its swirls before either reached the final wall. And all the while, the distance home grew so great that their faint radio whispers, traveling at the speed of light, took longer and longer to arrive. We speak to them now across the silence, measured not in miles we can picture, but in hours of light. A message from either craft needs the better part of a day to cross the gulf between us, and its patient reply needs just as long to return. And still, faithfully, across all that emptiness, they answer, for as long as their fading warmth allows. There is a great tenderness in that slow conversation, two small distant voices and our own, trading whispers across the widest distance any human hands have ever reached, keeping quiet company at the very edge of the Sunday's country. Think, too, of the sheer patience their journey asks of everyone who tends them. The people who built the Voyagers and first guided them were young then, and many have since grown old alongside these craft, following them outward across a working lifetime. A whole career can be spent in the company of a single spacecraft as it drifts from the planets to the edge of the Sunday's realm and beyond. There is a rare kind of devotion in that, a patience matched to cosmic distances rather than human ones. And the craft repay it faithfully, sending back their faint word from the dark for as long as they are able, a slow correspondence carried on across the better part of a century. Beyond the termination shock lies a quiet, thick region where the slowed wind piles up and swirls, a kind of quiet borderland between the Sunday's realm and the galaxies. And beyond that, farther still, comes the true wall, the outer skin of the bubble itself. It is called the heliopause, the place where the Sunday's outflowing breath finally comes to balance against the interstellar gas and can push no farther. Cross the heliopause and you have left the heliosphere entirely. You have passed out of the space the Sunday holds open and into the space that belongs to the galaxy at large. Voyager 1 reached that outermost wall in the summer of 2012, and the moment it crossed was unmistakable. The character of the space around it changed. Particles from the Sunday fell away, and a denser, cooler sea of interstellar particles rose up to surround it. After 35 years of flight, a small craft built by human hands had crossed the boundary of the Sunday's own bubble and entered the space between the stars. Voyager 2 followed it across in 2018, on the far side of the bubble, confirming what its twin had found and adding a second reading of the wall from a different door. Two lonely travelers, sailing outward on separate roads, both arrived at the edge of the world and passed gently through. We do not often stop to consider what a tender thing that is. These two craft are small, no larger than a modest car, and they carry instruments far simpler than the telephone resting somewhere near you now. They have been sailing for more than 4.5 decades. Their signals, when they still whisper back to us, take most of a day to cross the distance, traveling at the speed of light, and yet needing all those hours to arrive. And they have carried us, in feeling if not in body, all the way to the shore of our own bubble and just past it, to stand at the boundary between the Sunday's country and the wider night. They are the only messengers that have ever reached that far. Everything else we know about the edge, we have had to learn without ever going there. By gathering the faint light and fainter signals that drift back to us across the immensity. And in trying to map that edge from within, we have run into one of the loveliest open puzzles in all of astronomy. The simple, unanswered question of what shape our bubble really has. Here is something that may seem hard to believe, and yet is simply true. We do not know the shape of the bubble we live in. No craft has ever traveled far enough to turn around and take its picture whole. So the heliosphere has never been seen from outside, and its true form remains one of the gentlest open questions in science. We live inside a room whose walls we have touched in only 2 places, and whose overall shape we are still trying to guess. Think of how difficult that is. To know the shape of a thing, you usually step back and look at it from a distance. You cannot easily learn the shape of a house while standing in one of its rooms, and the heliosphere is so enormous that stepping back from it is beyond us. Even the Voyagers, after nearly half a century of flight, have only just poked through its wall at 2 small points. They are like 2 ants that have walked to 2 spots on the inside of a vast tent and felt the fabric there. And from those 2 touches alone, we are trying to imagine the whole shape of the tent above us. It is a wonderful puzzle and a humbling one. We are not entirely without help, though, and the way we gather clues is itself a quiet marvel. A spacecraft called the Interstellar Boundary Explorer, launched in 2008, circles the Earth and does something clever. It cannot see the distant wall of the bubble directly, but it can catch the faint particles that come flying back inward from that wall, atoms that were flung off the boundary and drift home across billions of miles to be counted. By patiently tallying where those returning particles come from, all across the sky, the little explorer has slowly built up a map of our bubble's edge, drawn not in light, but in the soft rain of atoms returning from the frontier. From its patient counting, a great glowing band appeared across the sky, a ribbon of returning particles no one had predicted, still not fully understood, a further gentle mystery folded into the first. Help is on the way in the patient manner of these things. A new explorer has been prepared to carry this work further. A craft designed to map the returning atoms from the boundary in far finer detail than before, to sharpen the blurred edges of our picture of the wall. From its post, out where the pull of the Sunday and the pull of the Earth gently balance, it will spend years gathering that faint inward rain of particles, filling in the map the earlier explorer began, and perhaps helping to settle at last whether the comet or the crescent is the truer likeness of our home. Little by little, touch by distant touch, the shape of the bubble is being coaxed out of the dark. There is something deeply calming in that patience, this long unhurried drawing of a map no one will ever see complete in a single glance. Consider too how gently this puzzle sits beside the great certainties of science. We can predict an eclipse to the second, centuries in advance. Astronomers can weigh a distant star and count the worlds that circle it. And yet, the plain outline of the shore around us, the simple silhouette of the bubble we have lived inside for all of time, remains a thing of soft edges and open argument, sketched in more than one way, none of them yet proven whole. The shape of the bubble is not only a matter of curiosity, either, for its form helps decide how well it shelters us. A bubble drawn out into a long tail behind the Sunday, or curled into a shorter crescent, would each guard the inner planets a little differently against the galaxy's incoming particles, and would each respond in its own way as the Sunday wanders through denser and thinner clouds over the ages. To know the true shape is to understand more deeply the nature of the shelter we have always lived within. So the careful people leaning over their maps are not only satisfying a wonder, though wonder alone would be reason enough. They are learning the outline of our home, the real silhouette of the space that keeps the wider galaxy softly at arm's length. And when scientists take all these faint clues and try to draw the whole bubble, they do not yet agree on what they find. Some see the heliosphere as a long, flowing teardrop, rounded and firm on the side facing the Sunday's motion, and drawn out behind into an immense soft tail, like the wake trailing a boat, or the tail of a comet streaming away from the light. Others, reading the same clues a different way, believe the tail may not stretch out so far at all, and picture instead a shorter curled shape, something like a folded crescent or a soft croissant with two rounded lobes tucked close to the Sunday, the comet and the crescent. Both are drawn from real measurements, and both may hold part of the truth. And the honest answer today is that we are still learning which is nearer to right. There is no unease in this uncertainty, only a kind of wonder. It means that the outermost shape of our own home, the great bubble that shelters every living thing we know, is still being sketched, still being argued over gently by careful people leaning over their maps. We have named nearly every star we can see and measured galaxies at the far end of time. And yet the plain shape of the shore around us remains a soft and open question, waiting on measurements we have not yet made and on journeys we have not yet taken. And here, at the far edge of the bubble, our long theme returns once more, quietly. The reason we cannot see the shape of the heliosphere is, at heart, the very same reason we have never photographed the solar system from above. In both cases, we are stuck inside. We are looking outward from within, never able to step back far enough or high enough or to the side enough to see the whole of what surrounds us. To know a shape, you must get outside of it and look back. And we, born on our fast sideways sheet, held in the innermost room of the bubble, have almost never managed to get outside of anything at all. Almost never, for there were two small craft that climbed a little way out of the plane after all, and one of them, long ago, turned around and tried. The Voyagers, it turns out, did not stay perfectly on the flat sheet either. Like Ulysses before them, though for different reasons, they left the plane of the planets behind. Their long gravity assists among the giant worlds. The same slingshots that flung them onward toward the edge also tilted their paths up and down out of the ecliptic. So even our two farthest travelers are no longer sailing along the level sea. They are climbing gently away from it as they go. Voyager 1, after its last great encounter among the outer planets, was bent upward and is now rising steadily above the plane, heading some 35 degrees north of the ecliptic into the sky of the northern heavens. Its twin Voyager 2, on its own separate road, was bent the other way and is descending, sinking about 48 degrees below the plane toward the southern sky. One traveler drifting up and over, the other down and under, both leaving the flat sheet farther behind with every passing year. In a sense, they are doing exactly the thing this whole journey is about. They are among the very few made things that have risen meaningfully out of the plane of the planets and into the open space above and below. Neither Voyager can send us a picture now, and there is a soft reason why. Not long after they finished their tour of the planets, their cameras were quietly switched off for good. Out beyond the giant worlds, there was little left bright enough to photograph, and the craft needed to save their dwindling power and their limited memory for feeling the invisible things, the fields and the particles and the wind. So the eyes of the Voyagers have been closed for decades by deliberate choice and cannot be opened again. Even if one of them could somehow be turned to look back down at the solar system from its tilted height, it has no working camera left with which to make the picture. Their looking days are behind them, and their listening days go on. Each is aimed now at the deep field of distant stars. Voyager 1 climbs toward the northern sky, in the general direction of a faint and far-off star. It will not approach for tens of thousands of years. Its twin sinks toward the southern sky, bound on its own long road through the dark. Neither will come near another star for an almost unimaginable span of time, longer than all of recorded history many times over. They are not going toward anywhere in particular. Each simply travels outward and onward, carrying its golden record and its silent cameras into the space between the stars, among the first small pieces of the Earth ever to leave the Sunday's bubble behind. And because they are always leaving, always facing forward, the one picture they can never give us is the one looking back. So the farthest travelers we have ever sent are, of all our machines, the least able to grant the wish at the heart of tonight, the simple wish to see our home from above. It is a gentle paradox worth turning over softly. The very thing that carried the Voyagers so high above the plane, their great slingshots past the giant planets, also aimed them permanently outward, so that height and homeward looking could never be combined in one craft. To rise, they had to commit to leaving, and to leave is to face away. A mission built instead to look back down would have to want that from the start, to trade the glory of the far frontier for the quieter prize of a backward glance. No craft has yet been asked to make that particular trade. But the wish remains patient and undimmed, waiting for the traveler who will one day be sent not to flee the solar system, but to turn and behold it. And so you might think, hopefully, that here at last is our chance. If Voyager 1 has climbed 35 degrees above the plane, then surely it could turn its cameras back and look down, and give us the picture we have longed for, the solar system seen from above. But the geometry, gentle as it is, does not grant us that. The trouble is direction. Those two craft are not hovering above the solar system looking down at it. They are racing away from it, outward, their cameras and instruments pointed ahead into the deep where they are going, toward the far stars and the interstellar dark. Yes, they climb above the plane, but they climb while fleeing, and their faces are turned outward, not homeward. To photograph the solar system from above, a craft would need to rise high over the plane and then look back and down toward the Sunday. The Voyagers rose over the plane and kept looking the other way, out into the night ahead. There is a tenderness in that, if you sit with it. Our farthest travelers have gone higher above the flat sheet than almost anything else we have flown, and they have carried our reach out past the very wall of the Sunday's bubble. Yet they were never able to give us the one view we most wanted of our own home, because they were always leaving, always facing forward into the unknown they were built to seek. They are explorers in the truest sense, pointed always at what lies ahead and never lingering to look back. The ones who go the farthest are often the ones with the least chance to turn around. And yet, once, one of them did turn around. Just once, and only briefly, and long before either had reached the edge, one of the Voyagers was gently commanded to swing its camera back toward the Sunday and take a parting look at the home it was leaving. It could not rise high enough to see the solar system spread out below it like a wheel. The craft was still far too near the plane for that, but it was far enough out and just high enough to look back across the whole span of the planets and make a single quiet portrait of the family it came from. That portrait is one of the most beloved images humanity has ever made. And understanding exactly what it shows and what it cannot show brings us at last to the tender heart of this whole gentle journey. On a day in the winter of 1990, out near the edge of the planetary system, far beyond Neptune, Voyager 1 received a gentle instruction from home. Its main work among the planets was long finished. Now, before it sailed on into the endless dark, it was asked to turn its camera around, back toward the tiny distant Sunday, and take one last set of pictures looking homeward across the whole breadth of the solar system. It was an idea championed by the scientist and dreamer Carl Sagan, who felt that a portrait of our home from the outside might teach us something no words could. And so, from more than 3.5 billion miles away, Voyager 1 made a family portrait of the worlds it had come from. In those images, the planets appear as faint points of light, each a small bead scattered against the enormous black, with the Sunday a brilliant pinpoint at the center of it all. And there, in one of the frames, catching a stray band of scattered sunlight, sits the Earth, rendered as a single pale blue speck barely larger than the grain of the image itself. Carl Sagan gave that speck the name it has carried ever since: the pale blue dot. Everyone who has ever lived, every city and every ocean and every quiet evening like this one, all of it gathered onto one dim point of light adrift in a sunbeam, seen from the cold outer reaches by a small, departing craft. It is perhaps the most humbling and tender photograph ever taken, and it has moved people to stillness for more than a generation. Making that portrait was not a simple thing, and the care it took only deepens its tenderness. Voyager 1 had to swing its camera back across the whole span of the planets and take frame after frame, more than 100 in all, sweeping slowly from the outer worlds, inward toward the Sunday, so that the separate images could later be joined into a single great mosaic of the family. Catching the Earth was the most delicate part of all, for Owls sat so close to the Sunday in that backward view that its tiny point of light was very nearly lost in the glare. A single pale dot caught, by chance, in a soft band of scattered sunlight. The whole sequence was made quickly, and then the cameras were closed for good, so that this backward glance became, in effect, the last thing the Voyagers ever saw. Their final act of looking was to look homeward. Carl Sagan, reflecting on that pale dot afterward, drew from it a thought that has never quite left us. Everything we have ever been, he observed, every ruler and every child, every triumph and every ordinary afternoon, the whole of our history has played out upon that one small point of light, a mote suspended in a sunbeam, seen from just a little way out into the dark. There is nothing heavy in the thought, only a great softening of scale, the kind that makes small troubles smaller and quiet wonder larger. And it came to us only because, for one brief moment, a departing craft was turned around to look back. Imagine then, what a fuller turning might one day show us, a craft risen not merely outward but truly upward, high enough to see not a pale line, but the whole round family opened out below, That is the picture still missing from all our albums, the one the family portrait gestures toward but could not itself capture. Voyager gave us the side view, taken almost within the plane. The overhead view, the true look down, waits still for a traveler willing to climb. For all that it could not show, the family portrait gave us something no top-down photograph ever could. A feeling of leaving, of looking back at home from the doorway on the way out. There is a particular tenderness reserved for backward glances, for the last sight of a place as you depart it, and Voyager caught exactly that for the whole Earth at once. Our world, made tiny wrapped in a chance beam of its own Sunday's light, seen by a machine already sailing away and never to return. Perhaps the overhead view, when it comes, will move us in a different way, with the calm of a thing fully seen rather than the ache of a thing left behind. Both are worth having. Each is a way of loving a home, one from the threshold and one from high above. But look closely at how that portrait is arranged, because this is the quiet point at the center of our whole night. In the family portrait, the planets are not spread out into a broad round wheel with the Sunday in the middle. They are strung out in a thin line, a row of scattered beads laid across the dark, one after another. That is because Voyager 1, for all its distance, had not risen high enough above the plane to look down upon it. It was still very nearly within the flat sheet itself, out near its edge, looking back across it almost edge on. When you look at a flat disk from its own edge, it does not appear as a disk at all. It appears as a line. So our one great portrait of the solar system is a side view, a glimpse along the plane. The planets flattened into a single row exactly because we made the picture from within the very sheet they lie upon. Let that settle softly, because it is the true shape of our longing. We have a photograph of the solar system, and it is beautiful beyond words, but it is a photograph taken from inside the disk, looking along it. What we have never once made in all our history is the other picture, the view from straight above. Our solar system seen from high over the Sunday's North Pole, spread out full and round beneath us. The planets no longer a thin line but a set of nested rings, circling the bright point of the Sunday, like ripples spreading on a still pond. The whole flat family laid open at last to a single downward gaze. That picture, the top-down portrait of our home, does not exist, not as a drawing made from imagination, but as a true photograph made of real light gathered by a real camera looking down. It has never been taken. In all the thousands of years that human beings have watched the sky, and all the 60 years we have sailed machines among the planets, no eye and no lens has ever risen high enough above the plane to look down and see the solar system whole. There is no sadness in this, only a soft and open wonder. It means that one of the most natural pictures we could ever wish for, the simple overhead view of the place we live, the family portrait taken properly from above, is still waiting to be made. Such a picture is a photograph from the future, a gift we have not yet given ourselves. And the wonderful thing, the thing to drift toward now as the night deepens, is that it is not impossible. We know, more or less, how it could be done. Somewhere ahead of us, perhaps, is the mission that will finally climb high enough over the Sunday to turn its camera down and take the one photograph of the solar system we have never taken. So let us end the night by dreaming gently and within reason of the mission that could finally take the picture. It is not a fantasy. Engineers and scientists have sketched real designs for a craft that could climb high above the Sunday and look down. And though none has yet been built and flown, the paths to it are understood. There is more than one way up, and each of them is a quiet marvel. One way is the way Ulysses and Solar Orbiter already showed us, only carried further, with a camera aboard from the start. A future probe could fly out to Jupiter, take the giant's great gravity assist just as Ulysses did, and be flung far up out of the plane. But this time it would keep climbing all the way to a steep enough angle that its camera, turned back toward the Sunday, would look down upon the whole flat family of planets from high above. It is the old trick, patient and proven, aimed now not at listening but at seeing. There is another way, gentler still, and perhaps the loveliest of all. It uses no giant planet and almost no fuel. Instead, it uses only sunlight. Light itself, though we never feel its weight, presses ever so faintly on anything it touches, and a large enough sail, thin as a soap film, and spread across a wide frame, can catch that faint and endless pressure the way a sailing ship catches the wind. A craft carrying such a sail could tack slowly against the sunlight, angling its great mirror just so, and over months and years spiral gradually up and out of the plane under nothing but the soft constant push of the Sunday's own light. No engine, no fuel to run dry, only patience and a sail and the light of the star it means to rise above. Bit by bit it would climb, until one day it hung high over the Sunday's pole, held there by sunlight alone, its camera at last pointed straight down. This is not merely a hopeful idea on paper. Solar sailing has already been shown to work. More than a decade ago, a small spacecraft unfurled a broad gleaming sail out in space and let the pressure of sunlight push it gently along, proving that a ship can indeed sail on light alone, with no fuel at all. Since then, others have flown their own sails, tacking and turning on nothing but the Sunday's soft and constant push. The principle is settled. What remains is to build a sail large enough and patient enough to do the harder thing, to spiral not just onward but upward, climbing slowly out of the plane over a long span of years until it hangs high above the pole. Scientists have drawn up careful designs for exactly such a mission, a craft whose whole purpose would be to rise over the Sunday and look down. It has not yet been built, but nothing in nature forbids it. It waits only on our choosing to go. And if it were built, it would give us far more than a single beautiful photograph, though the photograph alone would be worth the whole journey. From high above the pole, such a craft could watch the Sunday's entire face turn beneath it, follow the storms as they wheel around the star, and read the polar magnetism that wins the great cycle. All from the one vantage that has always been denied us. The science and the wonder would arrive together, as they so often do. Yet, it is the picture that would touch us most, the plain overhead view of home, for every child who has ever traced a diagram of the planets, circling the Sunday and quietly wondered whether it truly looks that way. The answer has always been the same soft admission. We think so, but we have never actually seen. On the day that picture finally comes home, that long gentle uncertainty will close at last. It is worth saying that this is not a distant dream of centuries hence. The pieces already exist, scattered across missions that have flown or are being drawn up right now. We have proven the gravity assist that lifts a craft from the plane. A sail, too, has been shown to fly on light. We have built cameras that can gaze into the face of the Sunday and survive. What waits is only the will to gather these proven pieces into a single craft, pointed at a single purpose, and the patience to let it make its slow climb. In the quiet arithmetic of such things, the photograph of our home from above is less a fantasy than an appointment we have not yet kept. And then, imagine what it would see. Picture the view through that downward camera, the picture no human being has ever held. Below it, at the center, the Sunday, seen from directly over its pole, turning slowly on the axis we have never faced. Spreading outward from that bright center, the orbits of the planets, no longer flattened into a thin edge on line, but opened at last into what they truly are, a set of vast, nested, nearly perfect rings, one inside the next, each carrying its small world along its patient curve. Mercury's tide-quick ring near the middle, then Venus, then the pale ring that is the path of the Earth, then Mars, then the wide gaps and the great slow rings of the giants far out toward the edge. The whole solar system laid open like the calmest of diagrams, but real, made of true light. Seen from the one vantage we have never reached, it would look, more than anything, like ripples spreading on the surface of a still dark pond, frozen in a single quiet moment, with a cold bright point of light at their center. We have imagined that view for a long time. It hangs on the walls of classrooms and in the pages of books drawn by artists who had to invent every line of it from what they knew, because no photograph existed to copy from. Every flat map of the solar system you have ever seen is a guess at that overhead view. An artist's gentle fiction, a picture of a thing no camera has recorded. And somewhere ahead of us, quite possibly within the lifetimes of children now sleeping, a small craft with a wide bright sail or a bold probe flung skyward by Jupiter's hand may finally rise to that height and send the true picture home. On that day, for the first time, we will see our own home from above, not as a diagram or a dream, but as it really is. It is a soft and hopeful thing to carry towards sleep, the knowledge that so natural a wish is still unfulfilled and still entirely possible. The direction we have almost never traveled is still open above us. That photograph we have never taken is still waiting to be made. And the plane we were born upon, the flat, bright sheet that has held us for all of history, is not a wall but only a habit, one that patience and sunlight and a little more time may yet gently lift us out of. Now, slowly let us drift back down. Down from the high imagined vantage over the pole, down through the empty space above the plane, back toward the thin bright sheet where all the familiar worlds are quietly sailing, back to the level sea we were born upon. There is no hurry in the descent. We simply sink gently home, the way a leaf comes down through still air, until we are resting once more within the flat plane of the planets, in the innermost room of the Sunday's great bubble, exactly where the night began. Think back over the quiet distances we have crossed. We began with a simple noticing that everything we know lies flat on one thin sheet, and that we have almost never risen above it. From there we followed Ulysses out to Jupiter and up over the Sunday's poles, where it listened to a wind no one had felt before. Later we watched Solar Orbiter climb its patient staircase of Venus flybys to bring home the first true pictures of the poles. Farther out, we traced the Sunday's long breath past the last planet, into the great bubble it blows around us, and drifted with the Voyagers all the way to its distant wall. And we came, at last, to the one photograph we have never taken, the view of our own home from above, still waiting somewhere in the years ahead. None of it is anything you need to hold onto now. Let the planets and the probes and the poles fade softly, like the last images of a long, slow film, leaving only the quiet behind. The Sunday is still turning out there in the dark, as it has for billions of years, breathing its gentle wind, holding its great bubble open around us all while we rest. Beneath us, the plain is still there, level and calm and sure, and the direction we have never gone, the soft open space straight up, is not a thing to trouble the mind. It is only a reminder of how much wonder is still ahead, patiently waiting, in no hurry at all. So let your thoughts settle now, down onto the plain, down into the pillow, down into the deep and easy dark. There is nothing above you tonight but quiet, and nothing below you but rest. Wherever you are, and however far you have drifted, you are held here in the innermost room of the Sunday. Breathe out slowly and let the last of the day go. Sleep gently now, and good night.